Good morning again and welcome to the second in-house webinar this fall. This is an initiative that we started and that we actually thought about at the DARIAH Strategy Days last year. The goal of this seminar series is to contribute to DARIAH becoming what is fancily referred to as a learning organization, i.e. We all have our day-to-day jobs to do in DARIAH. Also as scholars, we all have our areas of interest and increasingly very little time to go beyond the, the usual, what's part of our job or our academic niche. So this webinar series is about expanding our horizons and trying to be in touch with the latest developments in digital humanities, infrastructure building, and related fields. And the topic of today's discussion is the Time Machine project. And I looked up a very nice definition of it from the Time Machine website, which says the Time Machine builds a large-scale simulator mapping 2,000 years of European history, transforming kilometers of archives and large collections from museums into a digital information system. So, simple stuff. But all joking aside, I think this project, which really exists at the intersection of big data and infrastructure building and distant reading methods and geospatial humanities, is truly ambitious and truly exciting. And I think those of us who are working in DARIAH, for DARIAH, etc., should be inspired and will have a lot to learn from it. We will have two speakers today, and Iason, will you be the first one to go? No? Okay, Melvin. It was a 50-50% chance for me to guess this, so I guess, yeah. So Melvin is assistant professor in urban history and digital methods at the University of Amsterdam. He's also the local coordinator of the Amsterdam Time Machine and organizer of the Computational Humanities Research Workshop. His research focuses on the development and implementation of computational methods to study cultural historical phenomena with a specific interest in the formation and evolution of ideas and concepts in advertising discourse. He has a background in American studies, psychology, and cultural analysis. In his PhD research, he applied text mining to digitize newspapers to study the United States as a reference culture in Dutch public discourse on consumerism. We're very happy to have you here, and Melvin, the floor is yours.
Okay, so let me start. So the talk that Iason and I are going to give today focuses on the Time Machine project, and we're specifically going to look at the infrastructural components on behind these projects, and I'm going to focus on the Amsterdam Time Machine component, and Iason is going to focus on the Antwerp Time Machine. So that's the short overview of the talk for today. I'm going to start now by a brief introduction to the Time Machine project, and I'm going to use a short video that the Time Machine organization has produced.
The continent, Europe. In archives, beneath stones, in crumpled maps and winding streets, in pictures and paintings, in the depth of its green forests, history in Europe lies everywhere. How does one preserve and explore such a dense and fragmented past? How does one bring it into resonance with our contemporary world? In 2012, the Digital Humanities Lab at the École Polytechnique Fédérale de Lausanne launched the Venice Time Machine and offered unique virtual immersion into history, thanks to the development of big data and artificial intelligence technology. Since then, dozens of European cities have taken similar steps. Each now contributes to the creation of a unified temporal exploration tool accessible to all. All these initiatives are now gathered within a consortium that groups together more than 250 European partners, universities, archives, research centers, and also private companies. Time Machine participants include historians, engineers, geographers, developers, entrepreneurs, researchers from a variety of backgrounds, as well as ordinary citizens, defenders of their heritage.
Chaque ville du réseau de la Time Machine pose des défis particuliers. Et donc chacune des équipes qui reconstruisent Paris, reconstruisent Budapest ou reconstruisent Amsterdam ou Anvers nous permettent de développer des compétences spécifiques.
So this trailer gives a short overview of the giant scope of the project, and one of the important elements of the project is the further digitization of historical data. And using this data, we can generate models and maps and ideas about the past and also about the past, and also we can use it to test historical hypotheses, which can then further our understanding of the past. And we do this as part of the larger Time Machine project. We do these undertakings in the form of multiple local Time Machine initiatives that very much rely on local municipalities, research institutes, and heritage organizations that all help to further develop these local time machines. And here's an overview of some of these local time machines. And in what follows, I will describe the strategy that we use to develop these local time machines. And I will focus specifically on the Amsterdam time machine. So here you can see a schematic overview of the development process. There's a lot of different elements in here that might seem a little bit overwhelming at first. But I will turn to some of these components and give some examples of the processes that underlie these components that will hopefully make it clear what's going on and how they all interact. So let us turn to the Amsterdam time machine. The Amsterdam Time Machine is a public resource that builds on the history of Amsterdam, and it's coordinated by the CREATE research program at the University of Amsterdam, and is powered by a wide consortium of people within academia, cultural heritage, but also the industry. And we study the city in the most broadest sense of the word. We study the city as it is documented, experienced by people, but also planned and imagined. And we use a wide variety of sources, both textual and visual, to give people access to the city as a unity of analysis for social historical research, something that fits within the spatial turn within historical research, where people started to focus on spaces as units of research. And we do this through methods that have been put forward in the field of digital humanities. So we use digital data and computational methods to create, link, and analyze data sets, and to make all kinds of methods of analysis that can help us better understand this city as a unity of research. So let us turn to the overview. I won't focus on the municipality aspect, in our case Amsterdam, but I will start by focusing on some of the projects that we have running in Amsterdam within the CREATE project and within the Amsterdam Time Machine. This is just an overview of some of the projects. The project on the upper left-hand side looks into the way artists operated in Amsterdam and how they emulated each other's styles and how the spaces in which they operated looked. The other project focuses on leisure and nightlife in Amsterdam, out on the town. Another project sets out to build a large historical GIS system for the Amsterdam Time Machine. We'll talk a bit more about that in a minute. And the last project is focusing on how people lived and worked in 19th century Amsterdam. And using examples from these projects, I will show how we operate within this larger framework that's represented on this slide. So when we have a project, one of the things that we do in this project is that we develop operators. And these operators can be seen as ways to do something in this project, ways to do something with the source material in the project, which can then lead to reusable code that other people can also use in other projects or in other local time machines. And these operators can be applied to, for instance, the data. And one example is in the Living and Working in 19th Century Amsterdam project. We work with population registers of Amsterdam from the past, which provide us information on where people lived, where they were born, their addresses, their occupations. But these are available in physical form. And one of the steps for us was to use software to transcribe this into a digital form, and then also use this information that is stored in these population registers to then store that as something that can help us say something about American nightlife, for instance. There is information there on people that owned restaurants or bars or cafes and where these people lived. So we can then develop methods to extract this information from these physical sources that are available in Amsterdam, and then create a data set of information on American nightlife that can be then used to further explore trends in the, for instance, social mobility of people or the urbanization processes in Amsterdam. A similar project focuses on the role of cinema in the Amsterdam context. And for this, we created algorithms to extract movie information, movie screening information from newspapers. We have a large digitized newspaper collection in the Netherlands called Delver, and there are all kinds of screening information available in these newspapers, but getting them out there and also linking them to a database that we already have of movie information is one of the aspects of this data extraction, this operator. So in the context of this cinema project, the goal is to extract additional movie information from sources such as these newspapers, and then link this to already available information on movies in the Amsterdam context. And what we also do in this project is make available the algorithms to extract this kind of information from newspapers, something that can then be reused for newspapers in a different context, for instance. So I will now turn to the second aspect that I will highlight. So the first one was, how do we get information out of these sources and how do we develop code and store this code? The following step is, once we have this extracted data that says something about Amsterdam, what we want to do is inject it or insert it into a larger data graph, a graph of linked data that stores all these separate data sources within this Amsterdam Time Machine project. And this linked data source for the project is called ALIDA, the Amsterdam Linked Data Graph, which consists of all kinds of different elements related to different types of data. So on this graph, for instance, we see On Stage, which is a repository of historical cinema or theater plays in Amsterdam, so screenings of theater with all kinds of information that is then also linked to Wikidata, for instance. But another data source that we use is called ADAMLink, which contains all kinds of information on on the level of the streets in Amsterdam. So it contains information on the geometry of a street. As we can see here, we see a polygon that indicates where a street is located in Amsterdam. And for every single street in Amsterdam, we have a unique identifier that is stored in this data set, this add-on link data set. And what's really handy here is that we can use this unique identifier on the street level to then link all these different elements within the city space of Amsterdam to this unique identifier of the street. Because of course, street names can change, but this identifier stays the same. So even the same identifier can refer to changing street names over time. So we use this add-on link very much as something to tie the geographical information together. So then, as we go along with this project and more projects are starting up, we try to follow this process of extracting information, injecting it into the data graph to further expand all the information that is stored in this data graph. And once it's stored in this data graph, what it allows us to do is it allows us to build apps that can then query or analyze the information stored in this data graph. And one of these apps that's available is the HisGIS app, which allows us to explore geolocations in historical Amsterdam for different time periods. And we can do this on the parcel level, on the house number level, and on the people level. So once we have this unique identifier of the street, we can also go through time to see how things are connected here, zoom in using this information, and also get additional information on what was the purpose of this parcel in different moments of time. So we use the information stored in the data graph, and then we can use this application to interface with that information. A different example is Years in Amsterdam. It's a web interface that we built that allows you to select a particular year in the history of Amsterdam, and it then extracts all kinds of information for that particular year out of the data graph. So in this case, we see the street map of 1780. We see the mayors, and you can then click on these mayors, and you are then presented with additional information on these people. But also screenings in the theater, which is again then extracted from this Ecartico data set that I just referred. So here we sort of make an aggregate of information related to Amsterdam in that particular year. But there's also more analytical things that we can do with the information stored in the data graph. In the project by Weishwan, who looks at the living spaces of artists in Amsterdam, we can use information on where artists live to then calculate how would it look, what would the experience be for one artist if you would visit another artist? What would the trajectory be through the city, and what would they cross? And this can help us recreate the experience of the city in a particular time, and the experience of artists that were often visiting each other in a particular moment of time. So basically, it's sort of a Google Maps of the past, what we see here. And this comes from the project by Weishwan. She visualizes these also networks of early modern painters in Amsterdam. And what she does is something called a process which she calls deep mapping, where she takes the map of where people live and she adds all kinds of additional layers of information to these artists. So she has information on what people painted, in the styles that people painted in, but also the neighborhoods in which they lived. What types of neighborhoods did they operate in? So she basically creates a network graph and then transposes it onto the geographical information that we have stored in the linked data graph. This brings me to the final element of the schematic overview that I want to highlight. That is the 4D map. And why 4D? It's we're in the process of recreating the structures of buildings in Amsterdam, so the 3D structures of buildings, again, to allow people to experience the city as it was in the past. But the 4D element also allows us to change the time period. So almost like a slider through time, which adds the fourth dimension, the time dimension, which allows us then to create visualizations such as this, which shows the 3D information of all the buildings in Amsterdam, which we can then also change over time. An additional project here is the Virtual Interiors project, which not only looks at the outside of the buildings, so the external parts of the buildings, but it also allows us to explore the internal aspects of the buildings. So for some buildings in Amsterdam, we are recreating these the insides of these buildings, and we were also using information stored in the city archives on the products that people had stored in their houses to get a better idea of what one could find in a building. Additional information these projects give can be, once we know, for an artist, for example, how big the windows are in a house. Did they actually have enough space to do the work that they did? Was there enough light? How many hours of the day would enough light fall into the house for them to adequately do the work that they did? So this is another addition to this 4D map that's also stored in the data graph of the Amsterdam Time Machine project. And with this, I wrap up the presentation, and I'm happy to take any questions.
So thank you very much for this. And we'll move now to our second speaker. Iason is working as a tenure-track lecturer in digital historical geography at the University of Antwerp, and also as a leader at the Belgian State Archives, aiming at the activation of the vast online cartographic collection of this venerable institution. He has a background in geography and history and has spent most of his postdoctoral years at the University of Antwerp, where he was coordinating the construction of the Antwerp Time Machine and historical Antwerp infrastructure. Iason, over to you.
Yes, thank you for the introduction. I will pick up where Melvin left and introduce the Antwerp Time Machine, so one of the other local time machine initiatives within the broader European time machine context, which was already shown in the video at the introduction. Wait, I just have to find... Yeah, and I tried to fit my presentation in kind of the same scheme as Melvin already presented with the components. So I start with the project itself. And this is the Antwerp Time Machine conceptually. It starts, not coincidentally, because I'm his GIS person, so to speak. It starts with the spatial database, the historical Antwerp database. And we actually try to include all kinds of other sources based on the spatial location that is found within these sources. So we have a spatial component at the center of the entire infrastructure that is the Antwerp Time Machine. Furthermore, it's a coalition of separate institutions, both from the Antwerp city, where the main institution is the city archives, of course, that provide us with a lot of information to include into the system, but also on a provincial and on the Flanders level, we have partners that are more or less present within this project. Within our university, I am located at the Center for Urban History. That's where we started the project. And we work together with all kinds of other research institutions within the University of Antwerp, all having their own special expertise in these matters. As said before, I'm the GIS guy, so the rest of the presentation will be more about GIS than about digital text analysis or HR, VR applications, etc. But just to let you know that we are establishing a broader network with other expertise in this kind of things. So we all share kind of a same future vision. We want to include our historical data kind of in a 3D, 4D manner, where we project all this information on inhabitants, etc., onto the historical sources as maps or paintings, something like a Google Street View of the past, fitting within the broader vision of the European time machine. But this takes some time. And for the moment we are well, more or less working in the first, the second, and the fourth dimension of time and space. So over from just a rough introduction to the project, to the sources that we use, the spatial sources, we are gathering these in the Historical Antwerp project. This started already in 2012. So long before the vision of Frédéric Kaplan joined everybody together within the European time machine. And we started to build a digital spatial infrastructure to integrate all kinds of historical data to provide a social contextualization for other historical data that is to be integrated in the system based on space. So another researcher can bring on his own data, fit it to our system, and look up what was happening, for instance, in the rest of Antwerp at that specific moment in time. And to do that, we built high resolution micro level GIS layers of Antwerp over time. So micro level means that we try to go into the historical individuals or households, if not possible, for the entire city of Antwerp. And we did it in two phases or two stages. We started from 1800 to 1900, a pretty common starting point for historical GIS projects, and we extended it in time and space in a second phase of the project that is nearing completion in the following months. So we started in the 18th, 19th century. We're talking about the sources, and as we also saw somewhere in the presentation of Melvin, the first source of that is the cadastre of 1830, the first uniformal inventarization of all plots of Belgium, but also in other French, by the French rules, places in Europe, which consisted of highly detailed property parcel maps of the entire territory, combined with written documents that said who lived there, of who owned these plots, what they did for a living, where they came from, how much rent they had to pay, and what was found at these plots. We put that in the GIS, in first instance for the city of Antwerp, the inner city, and then we extended in the second phase for the urban fringe of Antwerp, which gave us different sources. Because before 1700, the nice maps of the 19th century, also in the 18th century present, were not as nice. Well, they were very nice looking, but not as nice to work with in the GIS, as you can imagine. If you go back in time before 1700, they are made up from bird's eye perspective, very hard to overlay with the present day situation. It gives all kinds of very weird distortions. And even further back in time, they are more or less sketched. So not really referring to a present day geometrically correct situation. So we also had to turn, as I will show you in the next section, to the written sources for these periods to find out where persons were located in space. So that is the challenge, which actually brings us to data, and mainly data extraction. How do we get the data out of these sources into a general system that allows you to question these sources? Well, if you have nice maps, that's pretty straightforward. You overlay these maps with the present day situation. You do that for a lot of maps, and you try to include and digitize these maps in order to put in other data. It's just a GIS process. This other data is stored to the shape files of these GIS layers, so to, for instance, the points, the lines, or the polygons, and they allow you to include written data, for instance, information on the owners or the types of plots to the spatial unit that are in your GIS. Pretty basic, pretty straightforward. As I said, it gets more difficult if you go back in time which gives us also a different situation for both the inner city as the urban fringe. As I showed you, for the 1830s, early 19th century, we have these nice cadastral maps, both for inner city as for urban fringe. Then we have pretty nice pre-cadastral maps. They look a bit different, but they are also pretty close to the present day situation. But if we go further back in time, we actually have what I call, and what I will show you next, a route-based taxation system. No more maps, but written sources. And to put all these sources in a GIS system, we use three techniques: the cadastral reconstruction, linear referencing, and what I called qualitative interpretation. That's more like puzzle your way out of things if you don't know exactly how it's located. And to show you these three processes, of which the second process is the most interesting for me, I will start with the cadastral reconstruction that we did on the data. That's pretty basic. You take your maps, your 1830 maps, you digitize these maps, you overlay it with an earlier map, you adjust your digitization, you overlay it with even an earlier map, and again, you adjust your situation, and then you link up the data to this. Works pretty fine, except for the period before 1700, and especially not for the inner city. No more maps, really detailed maps were made before the 1700s. So there, we turn to linear referencing. And that starts from this route-based taxation thing. And just to show you how that worked, you have a taxation officer. He walks through the entire city, and household per household, he notes down what these people, who these people are, what they did for a living, what they had to pay for a rent, and what their family was composed of. So they walk around the city in a specific order, and they write it down. There's no more maps, but for Antwerp, the building block structure is pretty consistent over time, and we can puzzle out this route. And if we puzzle out this route, we can connect the situation. We went back to 1584 by now. We can compare the situation to 1796, where we know all these households. So you have the houses in 1796 exactly located. And then we go to 1584, where we know the beginning and the end of every street where the taxation officer went. And in between, all the other persons in the street are listed in the written sources. We puzzle out these corner points. We put in between all the other households. And by following persons over time, we can, but this is very labor intensive, the following, we can readjust the system and spread the interlying households better and more fitting to the more fitting to the realistic situation in 1584. That looks like this in GIS. Since we're talking about data, I'd like to show you some of the work that is behind. Here we have the situation of 1830, all the plots as derived from the cadastral inventory. We have the center points of all these plots. You have to put the center points to the corners of the streets, because we are going to work with this line, this route-based taxation system on building blocks. So we also discard the inner structure of these building blocks. We discard the plots, they are not the same in 1584. Then we find our corner points, which are found in the written source of 1584. We do some GIS things, we simplify the system even more, and we plot in between all the other houses. And this gives us, for 1584, about 13,250,000 households plotted in the GIS system with quite a high quality, quite close to the situation as we think as it was in this period, with attached to each of these households all the information that was in the written source. So the owners, the renters, their profession, their names, their gender, their marital status, etc., etc. It's a pretty rich system. Then last thing I will be pretty shortly about this is just, if you do not have a route-based system and you do not have appropriate maps, but you have written sources, you can puzzle them out by taking the relative locations of these plots as mentioned. to each other and project them on a more recent maps and puzzle out where the situation prior to this map was located, probably. That gives us, well, I try to fit it to the system, kind of a 4D map. Actually, we skipped the third dimension. We have place and time in this thing, and it gives our system that goes from 1984 back to 1898, 1830, 1796, 1755 in between already, 1698 and 1584. Each of these plots or points is one spatial unit, one household or one house with all this information attached to it. This is the core of the Antwerp time machine. This is where you attach the other information like images or other sources towards. This is the spatial backbone of the system. And that allows you to do some other things. This is kind of a scientific infrastructure project. We also try to open this up to the general public. Therefore, we made an application that I will show you in a short video clip. Not as nice as the one from the European time machine. It's more or less an interview with a local radio station that I translated or subtitled myself. So we go on to that right now. It shows you the app that takes some of this data for free time layers for quarter of the historical center to the streets, to the local people living or walking around in Antwerp.
Onderzoeker Iason neemt ons mee Sint-Andries in met de app. De tijdmachine Sint-Andries.
We lopen nu in noordelijke richting de Kloosterstraat uit en wandelen eigenlijk de oever op. En daar zien we een aantal vrij authentiek uitziende woningen staan. We zien die ook, want we lopen nu op de kaart eigenlijk over 1898, zien we die op de kaart ook al verschijnen. En deze woning blijkt in 1898 een herberg te zijn geweest die werd uitgebaat door de familie Bergmans.
Zeg nu zelf, het geeft een wandeling hier een extra dimensie. Voor ongeveer elk huis kan je zien wie er in de jaren 1584, 1796 en 1898 woonde. Vandaag wordt er hier bijvoorbeeld verbouwd. In de 19e eeuw was het een sigarenwinkel.
Voor elk huishouden weten we wat de mensen deden, wat voor beroep ze hadden dus, en hoeveel huur ze moesten betalen bijvoorbeeld, of wie de eigenaar van hun gehuurde woning was. En wat er eigenlijk achter zit zijn diverse geschreven bronnen die wij gecombineerd hebben met kaartmateriaal.
En zo ontdek je al wel eens iets nieuws. Pal naast het Mercator Orteliushuis is nu een winkel, maar enkele eeuwen geleden was het helemaal anders.
Hier was eigenlijk een heel klein smalle zijstraat, een heel stuk achter het blok door. Met zeker een 8-tal verschillende huishoudens of woningen die daarin gelegen waren.
En wie er woonde, ook dat is geen geheim meer.
Voilà, that is the application, the first public viewer of the Antwerp time machine. We will present other viewers in the following years, I hope, but this is the first realization for the bigger project. I had some slides for the case that the video would not work, but as you probably saw in the video also, it allows you to walk over historical maps. It allows you to know everything about the former inhabitants. This is the layer of 1796, where we have even the children of the families for each household located with additional pictures if we knew where they were located. And if we did not know where these pictures were located, we have kind of an interactive component where people are asked to recreate an historical photograph or painting. They take the picture again and we get sent back the coordinates so we know where this was located in the city. That's really short about the Antwerp time machine and mostly the part that I was busy on. A smaller part, or not a smaller part, an important part that is not present in the data graph. It's also maybe of less interest to you. I'm not sure about that. But actually what we should keep in mind is that we try to build these systems to do research. It's not all about the data. It's not all about the infrastructure. It's also about facilitating further research with this data. And just to show you what we can do with it, I have some examples. We go back to the project, the research from the project. For instance, we can do research on the rental values in 1813 in this instance, and find out what were the richest or the less rich parts of Antwerp in this period over time. Since we have everything on a spatial base, you can conduct this kind of analysis over different periods of time. On the left here, you see 1584. The reds are the rich neighborhoods. And we have done exactly the same analysis, the same parameters on the 1830 situation with comparable data, which allows us to find that the central market of Antwerp was far less dominant in the 19th century, while we see more rich neighborhoods popping up in the the outskirts of the urban center of Antwerp. It also allows you to do analysis on, this is one of our PhD projects, on the relation between water infrastructure and diseases in the city. This is pretty interesting. I have another slide on that. It allows you to do analysis on the social composition of the city. Where did certain profession groups lived in the city? Here, the one you see, the blue one, are the skippers. They lived near to the River Scheldt on the left side of the city of Antwerp. This is spatial analysis on the data that is in the infrastructure system. Here you see another, I have a few examples. Here you see the development of the rich urban fringe houses of the rich inhabitants of Antwerp. Where were they located? It was kind of a trend in the 17th century to have a house in the inner city and buy yourself a second, far more larger house with a nice park around it. And we see that happening at a specific location in the 17th century, and we see this process extending to multiple locations, with one very large that is at exactly the same place in 1830. An analysis on specific houses within the system. Here you see the slide of the diseases, the cholera epidemic in the 19th century, which you see spreading from the city center to more the outskirts area and moving backwards and getting less intense by the end of the 19th century. This is an ongoing research project. The last one I want to show of one of our PhDs, Rogier van Kooten, who is working about Antwerp around 1584, the Spanish problems that we had over there, and he tries to do more advanced spatial analysis, for instance, a space syntax analysis on the location of specific shops or specific people within the urban fabric of Antwerp, based on the infrastructure of the Antwerp time machine. And that's where I wanted to stop. Here are some websites if you want to find out more, and I hope you found this interesting.